So next I want to talk about the actual effect on test parts caused from solar testing. And there's really two main types of effects. You've got actinic effects and your heating effects. Actinic effects are basically chemical effects caused by radiation. And the most common type of actinic effects are both color fade and then deterioration and loss of strength. So for color fade, this is tested best by using some sort of full spectrum solar exposure, whether it be metal halide or xenon arc. And typically, to evaluate this, we're going to take measurements using a spectrophotometer or a grayscale, and we're going to take measurements both before and after testing to evaluate if there was any color fade. And then deterioration or loss of strength. This is caused because there's actual photochemical reactions that take place during solar testing that can break down the bonds of both polymers and elastomers. And again, we want to make sure we can accurately evaluate this too. And the way we do that is by material testing, such as tensile testing, compression, bending, or flexural modulus testing. And the next type of effect that we might see on parts is heating effects. So solar radiation is going to provide a different type of heating than heat aging, similar to the infrared radiation testing that we talked about. It's going to have directional heating. So you're going to have different parts that are going to heat up at a different rate and to a different temperature than other components of your part. And this is going to depend somewhat on the actual material properties. The different materials are going to have different absorbance and reflectance properties. So that's going to affect their heating during testing. And because of this, you're going to have components that might expand and contract at different rates. So this is going to potentially cause a lot of stresses at component interfaces. And ultimately, all of this can lead to warpage. And the way that we like to check warpage is by using a photogrammetry system. And these are some images of an output of photogrammetry. Basically, the way this works is we take snapshots of your parts both before testing and after testing, and then overlay those images. And you can see this is the output we get. It's essentially different displacement vectors giving you an easy way to see how your part's deformed. So in this case, you can see we've got our total displacement up in the top left-hand corner, and then we also break that down to X, Y, and Z, all the three orthogonal axes.